Hello and welcome back. In this video we'll be looking at the next homework assignment on geometric equations. So to begin with, we should remind ourselves some terms. We've got length, area, and volume. And length, more or less, is just going to be the distance between 2 points, just how long this little line is. And we could measure length in things like feet, in inches, in meters. These are all common ways to measure length. Area is going to be sort of the space taken up by a shape. So for instance, the shape could be a square, we could have a triangle, we could have a circle, we could cut these shapes in half, we could glue them together, and area is going to be the sort of the space taken up by the shape in the middle. And when we calculate area, we're normally going to be multiplying two lengths together. And if we multiply feet times feet, we'll get feet squared, or square feet. We could get square inches, we could get square meters. Area is always going to have square feet or feet squared. This is an important way of distinguishing between length and area. And volume is again going to be the space taken up by an object. So for instance, if we have feet cubed or cubic feet, this is going to refer to the volume of that. We could also have shape, for instance, like a cylinder. So the volume taken up by a cylinder, kind of like a paper towel roll or a toilet paper roll. We could also have cones, which kind of look like pyramids with circular bases. We could have spheres, and we would just be looking at the space that they take up, and this is the volume. So I think we'll start with area, and we'll look at some common formulas for finding the area. So for instance, a square is when we have 4 equal sides. So if I look at the side length, all the side lengths should be the same, so they should all be S. And in particular, for a square, we want all of these angles to be right angles, meaning that they meet sort of perpendicular. They when they cross each other, they should form this nice, really nice angle. You'll just have to excuse my poor drawing. The area of a square is going to be s squared, or s to the second power. That's why we call raising something to the second power squared. It's because it refers to the area of a square. The perimeter of an object is the length of the outside. So here, if we travel along the top, so that's S long, S long, S long, and S long. So you can see that we just have 4 sides. Each of them are S long, so the total length is just going to be 4 times S. So squares are quite nice. So let's do an example question. If a square is 5 feet on each side, what are the area and perimeter? And what about a square that's 10 feet on a side? Well, we know that the area of a square is going to be the side length squared. So it's going to be 5 squared, so it's going to be 25. And it's 5 feet times 5 feet, so we will get feet squared at the end. The perimeter, the length of the outside, again, if it's 5 feet on a side, and we travel 5 feet, 5 feet, 5 feet, 5 feet, well, we've traveled 5 feet 4 times, which is going to be 20 feet. And again, perimeter is a length, so it's measured in feet. Area would be measured in feet squared, for instance. But if we up the length, if we double the length of the sides, what happens to the area and the perimeter? Well, the area is now going to be 10 squared, which is 100. And again, area, if we're working in feet, this will be feet squared. But the perimeter, on the other hand, if each side is 10 feet long, that's 10 feet, 10 feet, 10 feet, and 10 feet. Overall, that's 4 sides, each 10 feet long, so that's going to be 40 feet in total. One thing that you'll notice is that the area increased a lot. We went from 25 up to 100, so we increased 4 times. whereas the perimeter only doubled. And this is what you'll see often. If you double a length, the area will actually grow more than double, in this case 4 times. Triangles are quite nice, and we'll look at right triangles. So a triangle will have 3 sides, hence the tri part of the triangle. It'll have 3 sides, and a right triangle is one that has a right angle. So again, a right angle is like one in the corner of a square where the lines are perpendicular. They'll cross each other very nicely. So as long as we have one corner that is a right triangle, or sorry, one corner that is a right angle, this is called a right triangle. And the area is pretty straightforward. It's just going to be 1/2 the base times the height. The perimeter, on the other hand, is just going to be the sum of the lengths of the sides. So it's going to be B plus H plus L. So the perimeter is normally pretty easy. It's just going to be the sum of all these. The area is going to be what's a little bit more difficult. But a triangle, we normally think of as kind of half of a rectangle. So it's going to be half the base times the height. And the base and the height, I do want to clarify, the height doesn't have to be distance up and down. The base doesn't have to be distance across. If our triangle is sort of at an angle like this, notice that the base and the height are both next to this right angle, and then we'll have this other length along the other side, which we'll call L. So having the base and the height, they are the sides that are next to the right angle. So this is how to remember this. It's just the sides next to the right angle. So what's the area of the following triangle? So let's fill these in. So how do we find the area of the triangle? Again, we've got our right triangle because we have a right angle. And what I'll do is I'll take the area. It's going to be 1/2 the base times the height. And the base and the height are going to be the 2 side lengths next to the right angle. It's going to be 6 and 8. So it's going to be 1/2 times 6 times 8. My B's look a lot like 6's, so I apologize for that. So 1/2 times 6 is 3, times 8 is 24. And again, this I haven't included any units here, so it's just going to be 24. However, let's add some just to make sure. If these were in meters, if I had 6 meters across, 8 meters down, and then 10 meters diagonally, this is going to be area. So it's going to be area is going to be meters squared. Again, for area, it's always going to be square units. Then we'll look at parallelograms. Parallelograms, maybe this is a shape that you haven't heard of too much before, but it is a shape with 4 sides, and the sides are going to be parallel with each other. Parallel meaning that they're running essentially in the same direction. So the top and the bottom, if I had drawn this a little bit nicer, you can see that they're both going left and right. And then the two sides are also sort of pointing in the same direction, not necessarily straight up and down, but pointing in the same direction. This is a parallelogram. A particular type of parallelogram, which is really nice, is a rectangle. Rectangles are when the 2 parallel sides, some of them are going straight up and down, some of them are going straight across. So both of these are parallelograms. This is just a nice parallelogram called a rectangle. Furthermore, how do we find the area of a parallelogram? Well, we find the height of a parallelogram. So this is going to be the distance from the top to the bottom, and we find the length of the bottom. So the area is going to be base times height. In a rectangle, this is pretty easy because the base is going to be this distance, whereas the height is going to be the length of the side. If the parallelogram is a little bit wonky, it's a little bit tipped over, this height here is the distance from the top to the bottom. We just have to be told that. So rectangles are a little bit nice. The perimeter of these guys is also pretty easy. So the perimeter for a rectangle, well, what are the lengths? We have H and B. So the perimeter is going to be 2B, because I've got B plus another B, and I've got 2H because these two side lengths are H. So for rectangles, this is pretty nice. For any other parallelogram, again, these guys are going to be the same length. But what about the sides? Well, we just have to be told what they are. So again, this length is B, this length is B. If this is L and this is L, then the perimeter is going to be 2B, because I've got two side lengths that are B long, plus 2L, because I've got two sides that are L long. And that's all there really is to it. Again, perimeter is just adding up the length of the outside, which you just have to be told what all those lengths are. The last one that I'll talk about is the circle. So a circle, we'll know what this looks like, and there are a few terms that we'll want to know with this. The radius of the circle is the distance from the center to the outside. So if I call the radius r, it's going to be the distance from the center to the outside. So center to the edge of the circle. Diameter is going to be twice the length of the radius, and it's going to be the distance across. So the distance from one side of the circle to the other side. And again, what you'll notice is that if I start on one edge of the circle and I go all the way across through the middle to the other side, I've gone from the outside to the center, which is r, and then I've gone from the center to the outside, which is again r. So that's just 2 r's. So it makes sense that why the diameter should just be 2 times the radius. The circumference and area, these are a little bit trickier. So the circumference is going to be 2 pi r, and this is just the perimeter. It's just a fancy word for the perimeter specifically for a circle. Circles will have circumference, and this is just a formula that we'll have to remember: 2 times pi times r. The area, again, is just going to be pi r squared. So pi is just this number that comes up from circles. So this is exactly where this comes from. It's going to be pi r squared. Let's do an example. So here we have, we want to find the area and the perimeter, so the perimeter being just this outside, of the shaded region. So what I want to do is calculate the area here, and this perimeter. So what I need to do is I need to recognize that there's a few shapes in here. So if I draw this line in the middle, what this is, I have a rectangle with a little square cut out of the middle. How do I know it's a square? Because we've got the same side lengths, 5 and 5. And I've got a little half circle on the outside. So to find the area, I want to find the area of all of the red. So I'm going to start with the area of this little semicircle on the outside. So again, the area of the half circle, well, I'm just going to take the area of the circle, which is pi r squared, and it's only half a circle, so I'm going to divide it by 2. Okay, that's it. It's just a half a circle. So what is r? So r is going to be the distance from the center of the circle to the outside. But you know what? The distance from the center of the circle to the outside, it can be done in any direction that I want, including straight up. So if this side length is 10, that means that this whole length is 10, and half that length is going to be 5. So it's going to be pi times 5 squared divided by 2. So this is the area of this half circle. And what I'll need to do is find the area of the rest and add it to that. And I'll do this in the next video.